Hi everyone, this is a tour of my HyperCube. It's an ongoing project. As you may see, the frame isn't completely ready. There's no panels yet, but I'm getting there. The goal for this printer is that it should be completely silent when it's finished. So for starters, I switched out the regular E3D V6 Harden fan with a 40mm Noctua fan. Another great way to reduce noise is to add dampeners to your stepper motors. Just remember that they do have a top side and a bottom side, so check how you install them. They do work in the reverse orientation, but you get a lot less noise from them if you install them correctly. I only use dampeners on the X and Y motors because the Z motor doesn't really do that much and doesn't really move since the bed is automatically leveled, and I try to manually level the bed quite often. I've seen a lot of people using rubber feet for their 3D printers. I only use like furniture feet because I think they're good enough and I don't really need to level anything. I made a choice sticking to aluminium rods rather than tubes or carbon fiber tubes since I found out they produce a lot of noise. I guess it's because they become sort of an echo chamber. Another great way to reduce noise is to use the TMC 2100 or 2130 stepper motor drivers. They use 256 microsteps, which makes your travel moves and general moves along the X and Y axis completely silent as well. Since you can control the amperage of the TMC 2130 drivers, you don't need a fan cooling the stepper drivers. 2130 drivers also comes with sensorless homing, which reduces the amount of wires going from the gantry down to the mainboard. Another great way to reduce noise is to use an ATX power supply. This one comes with a 120mm fan, which makes the PSU almost completely silent. The ATX power supply is connected to all parts of the printer using the regular Molex connectors that comes with the PSU. The extruder is a 3mm version of the compact Bowden extruder. Most of the parts on this printer is printed in HIPS. Some parts are printed in PETG, and I think I will reprint most of the parts for this printer in PETG. There's no real reason for it. HIPS works great, but I get much better end quality or finish on the PETG parts. I use the same bushings and bearings as Tech2C does. I haven't found any reason to swap them out yet because they work so good. The bed is heated on one side using a PCB heating. It's aluminium with a PEI sheet on top of it. Underneath, I use insulating paper rather than cork, since I found that the cork doesn't retain heat even nearly as good as paper does. The bed is connected to the main board through a MOSFET, which is connected to the PSU. When I started this project, I didn't really intend to measure that much, so the frame is completely like eyeballed together. The corner brackets provide a somewhat 90-degree angle anyway, so you're kind of forced into making everything square. As long as your axis X, Y, and Z move freely before you mount the motors and belts, you should be all ready to go. The printer is controlled through a Raspberry Pi Zero W running Octoprint. Please let me know if there's anything in particular you'd like me to cover that you noticed in this video. The project is far from finished, but I think I'm getting quite close to where I want to be. The rest would only be cosmetics, basically. Some of you wanted to see tolerances and clearance leeway. So here are my measurements for my printer. As you can see, my rods are pretty darn close to 1 centimeter and 8 millimeter. no matter how much I push or twist, there's no play at all. The only place that I can actually make something move is on the X gantry, and I have to use a lot of force to make it wheel just a tiny bit.